All right, welcome to lesson 25, linear modeling, on page 221. Now, the process of linear modeling, if you think about chopping off the A and the R, you see the word line, and that means when we are graphing these, you will see that the graph is a straight line. So that's kind of something to keep in mind, and the reason we have a straight line is because we have constant change. In this particular problem, you receive $100 at graduation, and you commit to saving $10 each week. This $10 is a constant change. Every week your account is going to get bigger by $10. So that is why we have linear modeling, because we have constant change. Now this question talks about if you have, how much have you saved in 12 weeks? Well, just thinking logically, if you save $10 a week for 12 weeks, you will have saved $120. But don't forget, you started with that initial 100, which gives you a total of 220. And that is how the ordered pair 12, 220 came into be here. Now, a couple terms that are really important that you're going to need to know fall down here below this graph, and you will see the dependent and independent variable. Now, the x is always going to be the independent variable, and we know that if on graphing, the x is the horizontal axis. So in this case, the weeks of saving is the independent variable, and the dependent variable, which is always y, is the total amount saved. And if you think about that, the total amount that you save completely depends on how many weeks you've saved. Right? If you've only been saving for 1 week, then you've only saved an additional $10. But if you've saved 10 weeks, then you've saved $100. So the amount that you have saved depends on how many weeks you've been saving. And that's why the y is always the dependent variable. So what depends on what, basically, is what we're looking at for the independent and dependent variable. Now at the bottom of page 221, we get into two terms that are very important in linear modeling. And the first one is slope. Now slope, which we denote with the letter M, it talks about the steepness of the line. And just like with absolute and relative change, if you have a positive slope, that means increase, and if you have a negative slope, that means decrease. So positive is increase, and negative is decrease, just like what we've already talked about. Now, to find the slope, I'm going to erase that, I'm sorry, because I need room. But slope is found by taking y2 minus y1 over x2 minus x1. And you might just say, what are you talking about? That's crazy. Well, we want to know the change in the y values over the change in the x values. And if you think about the word change, the change is the difference between two values. And in mathematics, difference is subtraction. So where are we getting these x1, y1 and x2, y2? Well, they come in the forms of ordered pairs. So if we have two ordered pairs that fall on our line, between those 2 points we can find our slope. And then obviously we're going to get more into this as we do some problems, but the y-intercept is our starting point. Okay, and if you think about a graph, so if I just draw a coordinate plane here, the y-intercept is where our graph crosses the y-axis. So our y-axis is the vertical axis. So if I draw some lines on here, and you think about the point, this point right here has the ordered pair of 0, 1. This point down here has the ordered pair of 0, negative 3. Every ordered pair on the y-axis has an x value of 0. So your y-intercept will always have an x value of 0. That is very, very, very important to remember. So those are just two terms that you're going to hear me say a lot throughout the next few videos. All right, so through the 2 points that we have on this graph, we're still on page 221, we can find the slope. So if you notice, they give us the points 0, 100, and 12, 220. So we'll say this is x1, y1, and this is x2, y2. So using that model, y2 minus 1 over x2 minus x1, we see that we have 220 minus 100 over 12 minus 0. Notice that the ordered pairs are right on top of each other. So you see how 12, 200 is an ordered pair, and they are right on top of each other in the equation. So now when I go to simplify this, I end up with 120 over 12. And just like normal, we want to always reduce our fractions, and we end up with 10 over 1. So our slope for this particular problem is 10. Now I do want to go one step further, even though it's not asked in this question. I want to talk about what that means. So if I have a slope of 10 over 1, remember that in the top we have our y values and in the bottom we have our x's. Well, the y values in this case talk about amount saved, and the y values are number of weeks. So that means we have saved $10 for every 1 week that has passed. That's what our slope means, so you can interpret your slope. And we knew that already just based off the problem, but now we can actually see how it works. So let's go to the very bottom of page 221. It says, there's a question, how much savings would you have in 6 months if you stick with the plan? Well, remember that our x value here, x is the number of weeks. So you always want to make sure you're paying attention to your labels. Well, if it asks us for 6 months, well, we need to turn months into weeks. So we know there are approximately 4 weeks in a month. So if I multiply 6 months by 4, I will get 24 weeks. So I'm going to go ahead and plug in 24 for this problem. Now remember, we've got order of operations. So I'm going to multiply first and get 240. Then I can add these together. And after 6 months, I will have approximately $340 in my savings account. All right, so that is page 221. Now let's get into some application. On page 222, we've got our friend Bertha, and she weighs 240 pounds. She sets a weight loss goal of 2 pounds per week. And we're going to talk about how this all works. Well, they tell us that let's let X represent the number of weeks that go by. Find the linear model, which represents how much Bertha hopes to weigh after X weeks of the plan. Now, I think it sometimes is easier to answer question B first. What is X? Well, they've already told us that X is the number of weeks on the plan, right? And if you see letter C where it says unit of measure, we're in weeks. If you answer B with enough detail, then you've already answered C, which is kind of nice, right? Kill 2 birds with 1 stone. All right, so I want to show you this in terms of numbers. Okay, so Bertha starts in week 0, right? Her weight is 240. And I call it week 0 because that's like at the beginning, before she has started this plan. Now, after week 1, she is now at 238 pounds. And I know that because her goal is to lose 2 pounds a week. And after 2 weeks, her goal is to, oh crap, I got those numbers transposed, didn't I? She will have lost 2 more pounds, and now she's at 236. And after 3, she's at 234. So you can see each week it goes down 2. So when you think about, well, we know that this represents the X values because it's the number of weeks. This will represent the Y values. Well, what do those numbers mean? Well, her Y values are her new weight or her ending weight, depending on how you want to work it, right? So that's in pounds. So after a certain number of weeks, we can say how many pounds Bertha should weigh. Now, so her weight depends on how many weeks she sticks with the plan. And that makes sense in terms of if you think logically about weight loss. All right. Now the y-intercept. What is the starting point? Well, when Bertha started all this, she weighed 240 pounds. So 240 is the starting point. That's the y-intercept. And now what is the slope? or the weight or the rate at which y changes when x increases by 1 week. So in 1 week, what happens? Well, Bertha's goal is to lose 2 pounds. Well, if you want to lose, right, that's going down. So we are going to have a -2 for our slope. And of course, that's decreasing because she's losing that weight. It's going away. And now we can put those pieces together to write our model. We know that our slope is -2 and our starting weight is 240. So this is the model that we're going to use to answer the next few questions. And actually, I want you to hit pause and try to answer questions 2 through 6 right now, and then come back and watch them. So in question 2, week 4. Well, week 4 means I would put 4 in for x, because x represents the number of weeks. So y equals -8 plus 240. So after 4 weeks, Bertha will be down to 232 pounds. After 10 weeks, well, -2, now we're plugging in a 10 for x. So I get -20 plus 240, or 220 pounds. So after 10 weeks, she'll be down to 220. Now, in number 4, we're going to go kind of a different way with this. So we know our equation, but now they're asking us, she has a goal weight of 180. Well, remember that y is the ending weight, or her new weight. So we're going to plug in that value there and solve for x. So we're going back to our equation solving. If we want to get x by itself, we know we got to do the same thing to both sides of the equal sign. So I'm going to subtract 240 first. Those go away, and I have negative 60 equals negative 2x. I will then divide both sides by negative 2, and x equals 30. So if Bertha sticks with this plan for 30 weeks, right, our answer is in weeks because that's what x represents, she will be at her goal weight of 180 pounds. And now, dealing with this graph, we know from number 3 that after 10 weeks, she's at 220 pounds. That's not a good color. There we go. Just for fun, I went ahead and checked in for 20, so I did y equals negative 2 times 20 plus 240, and I got an answer of 200. So after 20 weeks, she'll be at 200. So when you plot a couple points, then you can say, all right, and pardon my that's a pretty straight line for drawing freehand, but then we can see visually what this looks like over time. So you can see that as the weeks go further, her weight goes down, and she's got a negative slope to this line because it's going down. And number 6, if Bertha were to up her weight loss to 3 pounds a week, how would the model and the graph change? Well, the model, hopefully you know, is pretty easy. She's still starting at 240 pounds, but instead of losing 2 pounds a week, she wants to lose 3 pounds a week. So the model simply changes from a negative 2 to a negative 3. And if you go back to this graph, okay, I just want to go with, I'm just going to pick 5. I'm going to change color so you can see it. If I plug a 5 into this, y equals negative 3 times 5 plus 240. That's negative 15 plus 240. That puts her at 225 pounds. So at 5, 225 is here. Notice how it changes, right? The trajectory changes. So it becomes a steeper line, which makes sense. If you're going to lose 3 pounds a week instead of 2, you're going to lose weight faster. So it's a steeper decrease in terms of how much she's losing. All right, let's move on to page 223 with the percent of smokers in the U.S. So you can see that this, this line that is kind of crooked, that is the percent of smokers. And then this black line that is straight, that's kind of our trend line showing line. So I'm going to come back to this and draw on this graph here in a minute, but let's first answer some questions. So we want to just talk from 78 to 2012. Well, what is the y value? Well, when thinking about x and y, if you go back to the graph, right, y is over here, and those are percents. X's are here, and those are years. So the y value would be the percent of smokers in the U.S. U.S. adults, to be more specific. And again, unit of measure, if you answered the first question with enough detail, you've already answered that. And x, we've already talked about that. That is the years. So the independent variable is years. Now, letter D, let 1978 be the starting point. So what they're saying is, let's pretend that 1978 is the y-axis. So instead of 78, we're going to have a y value, or an x value, excuse me, of 0. Now, if you think about that, if 1978 is the same as 0, then if I go 3 years later to 1981, that means my x value is going to be 3. And if I went 6 years later to 84, my x value would be 6. So basically, our x's are now the number of years after 1978. So it's important to think about that in terms of these problems. If they give you a particular starting point, you've got to use that to your advantage here. Okay, so let's answer this question now. What is the y-intercept? Well, if you see my pink line here, it crosses at 38. So my y-intercept, my starting point, is 38% of adults smoke. Okay, now finding the slope. I need points. If I go back to this, I'm going to use 0.38 as a point. And then if you look all the way down to the very end, in 2011, I have 22. Now, 2011, what would be x in 2011 if in 1978 x is 0? Well, how many years did it take to go from 1978 to 2011? Well, if you don't know, you could always subtract. And you get 33. So my x value would be 33. And that's how I figured it out. So I'm going to go ahead and get rid of this stuff because it's in my way. But that's how I got the 33 there. And now I can find the slope. So if I'm going to use x1, y1, x2, y2, remember, y2 minus y1 over x2 minus x1. And I get negative 16 over 33. Well, unfortunately, the question says when x increases by 1 year. So we want 1 to be in the denominator, not 33. So if you just divide these, negative 16 divided by 33, you get negative 0.48, which would be over 1. So you want to go ahead and do that if it tells you 1 year. That means you want a 1 in the denominator. And this is decreasing because it's negative. So we have a slope of negative 0.48. So now if we're going to write our equation is negative 0.48 x. My y-intercept is 38. Now, in 2 and 3, was the decrease in the percentage of smokers in the U.S. constant or did it vary? And then number 3, does the model assume constant or varied? So I'm just going to look at this graph again, remembering that this line here is the actual. Well, is that constant? No. So the actual piece, whoa, got ahead of myself. This piece is varied, right? The actual percentage of smokers varies from year to year, and we know that to be true, right? You might smoke this year and you don't smoke next year. It changes. But the model assumes a constant decrease. And that's the purpose of using a model, so that we can predict for future uses. If we can't predict, then we're not going to know. So we have a constant decrease for number 3. On page 224, which is where we're at now, we're going to answer a couple more questions using this. And you can go ahead and hit pause and try to answer these if you'd like. You're more than welcome. But did you need the data from 45 to 77 when looking at the rate of change? And the answer to that would be no. We changed the scope of our model to be from 78 to 2012. That's the data we were looking at. So the data from 45 to 77 really didn't matter. We didn't take any of that into account. Number 5, if the decrease had been constant to 78 to 2012, what would the estimated percentage of adults in the U.S. who smoke have been at the turn of the century? Now, turn of the century, right, is the year 2000. So how many years after 1978? Because again, remember, 1978 has an x value of 0. So I had to add 22 years, and that means for 2000, x is 22. So when I use my formula, y equals negative 0.48, plug in 22 plus 38. And then I go ahead and do the math, right? We're going to multiply first and then add 38, and you should get a value of 27.44%. So we estimate that in 2000, we're at 27.44%. And number 6, we want to compare that. Well, if you look back at the graph, let me find it. Let me clean this. Oh, yep, this graph will work. So 2000 is approximately right here. All right. Now, notice that the black solid line is the estimate. So we estimated here while the actual is down here. So when you're comparing, in this case, the actual is actually less than the estimate. And differently, if you look at like 1983, see how the estimate is up, or the actual is up there and the estimate is lower? So there will be some years where your estimate will be lower than the actual, or in 2000 where your estimate is higher than your actual. And that's going to happen because you are estimating. All right, number 7, let's use that model to estimate the expected percentage of adult smokers in 2011. So again, you got to think 1978 had an x value of 0. So 2011, we had to add 33, so x is going to be 33. So now in my formula, y equals negative 0.48 times 33 plus 38. So we would get an answer of approximately 22.16% of adults. And if you look back to the graph, it does, the point that they give us for 2011 is 22. So that's actually pretty close. All right, in 8 and 9, we're going to use this this age distribution, which we saw this when we did age dependency ratios back in Unit 1. So we are going to consider age 15 and over as adults, and we're going to use the census to estimate the number of smokers. Notice over here they've totaled things for you, so you don't have to add them all up. They've already done a lot of totaling for you. But let's get to number 8. According to the graph, what percent of adults smoked in 2011? Now this is the graph. So if you go back to page 223 at the top, look at the graph. 2011 estimates that 22% of adults smoked in 2011. So now, using the percentage from that chart and the census data, we can calculate the number of smokers because 22% of adults smoked, right? And the key thing here is of adults. Well, how many adults were there? So we know the adults are 15 and over, so I would take 204,775 plus the 39,178, and I'm getting this from this spot right here on the graph. And when I add those together, I get 243,953. So what does the word of mean? Well, of means multiply. So 0.22, right, 22% multiplied by 243,953. That's how many adults there are. And I get an answer of 53,670. And notice I rounded to the nearest person because you can't have a part of a person. And this is actually low because remember that we have millions of people in the U.S., but we're using what the chart gives us, so this is our answer. Now in number 9, should you expect the percentage of adult smokers to continue this trend indefinitely? Well, think about it. If you decrease year after year after year after year, eventually you're going to hit 0 and then negative. Is that, well, forget the 0. Is it possible to go negative? No. So technically, no, because we can't be negative. But, you know, just thinking through logically, do you think that we are ever going to come to a point in the United States where nobody smokes? I mean, to me, that is just it's hard to imagine. I mean, it would be great if it happened, but it's hard to imagine. So I would say that this answer is no. We can't expect this percentage to continue indefinitely because eventually we will be negative, and that can't happen. So it'd be great if we continue to decrease, but it might, you know, change percentages year to year. So that is video 1 for this section, so come back for video 2.